The 4K era is here. Is your network ready? 4K video, also known as ultra high definition video, got its name from horizontal resolution of approximately 4,000 pixels. Compared with high definition video, 4K video provides higher resolution and an image quality matching colors as seen by the human eye. With a rate of 120 frames per second, 4K video brings out more picture details for better visual experience. The improved resolution, image quality, and a frame rate mean that 4K video requires a transmission bandwidth of up to 30 to 45 megabits per second, many times the bandwidth that high-definition video requires. Large bandwidth is therefore the basic criteria for successful 4K video transmission. Let's have a look at a network model analysis that demonstrates the booming demand for 4K bandwidth. Each OLT is connected to an average of 2,000 end users. During the initial phase of 4K construction, high-definition and standard definition services occupy 95% and 4K services 5% of the required bandwidth. To transmit these services, each OLT needs a bandwidth of 14G, 2.9G for broadcast services, and 11.1G for on-demand services. Each broadband network gateway needs a bandwidth of 113G, 2.9G for broadcast services, and 10 by 11.1G for on-demand services. And each core routers needs 5 by 113G for total demand of 570G bandwidth. Now that 4K occupies an increasing share, a larger bandwidth is required. Ever run into constant buffering or pixelated images when watching videos online? These problems are worse when 4K videos are streamed on current networks. User experience reflects the network throughput, which mainly depends on network bandwidth, latency, and a packet loss rate. Higher latency and a packet loss rate cause a smaller throughput. Bandwidth is akin to the width of a road, and the wider road is the prerequisite for faster traffic. Latency is like traffic lights on this road. A car cannot travel quickly if it encounters many red lights. Packet loss is similar to potholes on the road, which hamper the speed of the cars traveling over them. Is there any way to ensure large bandwidth, minimal latency, and low packet loss rate of 4K video transmission? Let's take a look at latency and packet loss in current networks. During video service transmission from access devices to core routers, forwarding and switching are performed multiple times on intermediate switches and routers. Reducing this intermediate processing achieves lower latency and low packet loss rate. When WDM and OTN devices are introduced to a network, the transmission capacity of a pair of optical fibers is 80 times that of other devices. Large bandwidth is an inherent advantage of WDM and OTN devices. In contrast to switches and routers, WDM and OTN devices make up a hard pipe. After this pipe is constructed between access layer OLTs and core layer core routers, multi-layer forwarding processing is no longer needed. As a result, the network enjoys optimal transmission with zero congestion, zero packet loss, and low latency, as well as offers the best possible user experience. On current networks, services are forwarded multiple times during transmission from access layer OLTs to core routers. The local traffic occupies only 40% of the total traffic, with remaining 60% being pass-through traffic. This pass-through costs money. Deploying WDM and OTN devices lets services be directly transmitted from the core layer to each service layer for zero traffic service pass-through and significantly reduce the pass-through costs. Current network expansion requires individual on-site operations management of multiple pairs of fibers. WDM and OTN device deployment limits expansion procedures to only ONTs and core routers. Meanwhile, only one pair of fibers needs to be managed. greatly reducing the fiber maintenance workload at both ends. WDM and ONT intelligent O&M solutions are already in widespread use. These solutions support remote fault diagnosis, online network inspection, and automatic network optimization. Such functions help to greatly reduce network O&M costs. Better user experience, lower costs, and larger bandwidth are the forces driving a simplified network. Is your network ready for 4K?